Okay, people. This is this guy here. This right here, Odell Concrete, and he's about to say a falsity. How's that? An untruth. Let's hear it about post tensioning.
Potentially get cracking, but the idea behind the post tension is that even if it does crack, it still holds it all together, so it can't separate.
So if it does crack, it still holds it together. Well, that's contrary right there, isn't it? It's not holding together if it cracks. But let's say that for clarity, let's let it play and then say the secondary part let's deal with.
Although any cracking is really no concern with a post tension slab, it can crack wherever it wants, and when they tighten the cable up, it pulls everything together.
All right, it does not pull everything together as he stated. This post tensioning is in this profile here. It's going two directions. What he has here. He's also going to talk about it's two directional going on the slab. So you put tension in it. All right, you stress this. You put stress on it. Either one, you're pulling on one end or the other, and you stress it. And you got both sides here, and you're going to do both directions. You're going to go all the way around. Now, let's do a pad. And he said even if it gets cracks in it, it's going to close it up. Well, let's see here. Let's come across. And the post-tensioning is typically at the bottom. A lot of the engineers aren't speccing up the top at all. And this is where the problem is. I've mentioned in a previous video that the problem with that is it's going on expansive soil. That's what you're usually putting post-tensioning on out. And in this Arizona, Texas area. Expansive soil cation effect. Cation is the clay has a cation's effect, if you will. And that is, and I said the S on it, the expands and contracts. That the soil is able to hold more water, basically, than the molecules than regular soil would. This soil is clay, and clay can do that. Now let's put clay under here, expansive soil, under the entire thing. It's fully supported, as you see. As when he poured this, it was fully supported. But as the rain comes down, gets underneath of here, expands and contracts. Let's use this section here, and I'm going to do this. It's still a cable, but I'm helping you visualize the cable there. The soil underneath. Okay, let's do soil. So this would be your soil, but I'm going to remove it like that. I'm going to finish drawing first. So here's your soil, and it does expansion and contraction. Hey, Max. It does expansion, it's Max, and contraction. There's the post-tensioning, and your soil does this. This is retraction of your soil from the drying out. After it was put over this cloudy day, they poured it, and it's moist under there. It's expanded. It's supportive, if you will. It's pushing into. It's expanding out. It's literally pushing up, all directions. But it is a real physical force. This cation. But as it dries over the next few days with this pad over top of it, as it dries, it will retract, and maybe it retracts like that. Maybe this rainwater coming down here from the gutters on the outside of this pad over here when the roof gets put on saturates this area here under the soil there in the soil layer, if you will, and that causes this expansion and contraction here, just cycling, and eventually it pulls back. Right, I don't know where you're putting it. It pulls back, and that pulling back. Let's put the slab back together again, and there we go. We have the base, the reinforcement at the base, the bottom of it. And it pulls back, and now you have this section in here that's unsupported. All right, let's just stop it at the wall there. It's unsupported, but that was representing the soil retraction. You kind of can see it outside. For the most part, you can see it outside if you can see below it. A lot of times there's concrete covering that too, and you can't see it. But you might be able to see the soil settling. Depends how deep they dug the foundation, how much they exposed it to water, and the condition just before sealing, before putting the concrete on top. Often they put the concrete right on dirt, so that moisture comes out of that is pulled into the soil. That's part of the devil is in the detail. That creates a retraction. I've seen this retraction as deep as 4+ feet. It's crazy inside of a garage. I literally saw it myself. I loaded a video up on that. It was quite fun. I replaced that concrete there myself. A lot of them, when I say myself, a crew of people. So here's your post-tensioning and deflection in the pad, just because of the dead load of it, and the void that's created underneath. Let's create the void again. So now we're going to create a different void. Let's just say it's like that. This is where this post-tensioning works there. It's great if the deflection was happening around the middle of the pad. Here's the pad, right? It would be great if it was happening around there. That post-tensioning would be pretty practical. Now we have the post-tensioning. Oops. The post-tensioning at the ends. And you can go a little closer to that. You don't have to do that much retraction. So this part is in cantilever now. This section here and here, this section in here is in cantilever. It's not supported, but the midsection is supported. They have section all under it. So it's being supported as the cars drive up, the vehicles drive up, and the surge will put on brakes. Even the dead load of the slab itself hanging. And no reinforcement at the top. So no reinforcement up here, none. Up here, no rebar, no no post tensioning either, but no rebar. So this allows it to open up here. So this section can rotate down, and when you see it, you'll see a crack. Looking at it from the top view, and looking at a big garage 40 foot wide, you might see that it starts to crack like that. This is this cantilever flexing over. It cannot do it as long as it's supported. As long as it's supported, and I do mean that it's not a cave-in anywhere, if you consider that a cave-in, what I'm trying to describe to you. In reality, it's cat iron. So now let's go to, so he's saying it can close it up. Well, it can't close it up. It's not what it can do. It can't it can't put a slab like this weighing thousands of pounds per zone, if you will, where the post tensioning is doing. Roughly, this is 75 pounds per linear foot at 6 inches. So per 2 feet, it's 150 pounds square foot. But it's greater than that because his layout looks like it's like 2 feet per, like this is a 2 foot grid. So it's pretty huge. You're not going to close it up. It's too much weight. All right, so now you see the post tensioning. So there's no top steel here. All right, you see that they did grade down. It looks like the grade's up here. So it looks like water will be making its way down through these layers here, especially with the rocks to help it transverse the layers, get deeper and expansive. There's the chairs that hold this in place, and that's the profile. And you may see that it's more rectangular shape. It's not boxed. It's more rectangular in shape. Now, some of it is not graded properly. As you can see that this is high here, but low other places. So his grading is wrong. He's creating a profile in the concrete, which actually in this case is actually when you do that. So here's a profile. Let's go down. Let's go like this and then down and across. This detail here is creating a stress, pushing the concrete down. It's literally bending it, trying to crush it down, putting compression at the top of the slab. So here's a slab. So it's putting, because of that crown like that, it's trying to straighten out. When it tries to straighten out, it wants to push down to straighten out. That stress will always be there. So the blowout side would be over here underneath the pad. And this would put this in compression, which obviously allows for easier, since you're preloading it with a stress there, it allows for easier failure, more likely failure. and both directions, whether it be the cantilever I talked about or the blowout here. So the profile really matters, and often contractors don't respect how critical it is. Ultimately, they should have used a laser level to make sure the laser level of some type, or, you know, surveying equipment's too, it's rather to use a beep, 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 that type of thing. You can set it up real fast. I mean, idiot-proof it if they just stay within range of it. But this is unacceptable to me. This crown, that's just unacceptable. But obviously, the engineer or no engineer, somebody approved this layout one way or another.
Because the concrete's a little.
See, it's profiled pretty deep there, pretty high. And then if we look back at the back one, he's got gapping there. But the camera, I got to take in consideration the camera. Now he's going to misunderstand reinforcement. He's going to incorrectly state what's going on with something. See, now this is a dip. So that's a dip. So that creates a profile that's upward force, and this would be downward force. Downward force, because it goes up and it's trying to straighten up, and then we have this profile issue there. It really matters that they should not be walking on it, and they're walking on it. They'll be stepping on it left and right, as I saw in a few minutes. Like the guy right here, he's walking on it. The chairs aren't designed to hold people. They're designed just to place reinforce the tension, the rod. In this case, it's greased sheathed post-tension cabling, greased in that inside, not the outside, that it will allow it to pull. The cables will have less friction in them, to reduce friction to allow it to be tensioned. So you see now, error, and it's critical that you don't do that, and that might be bent also. That has the effect of, and he's going to say it incorrectly. Let's look at it from the top. So here's straight, right? That's just pulling it straight. Now if it's curved, and you see it's even if you were on the same plane, if it was level like that, and not up or down, but level, but the curvature looked like this. When you go to tension it, you're now putting compression between, you're putting a force in this direction. And of course, tension on this side when you do that. All right, let's go.
On the wet side, it's not really stacking up in that.
And as you can see here, what I'm talking about. So this is not straight.
Stem wall. This load looked a little wet, and it's also due to the pressure. There's a lot of pressure coming out of the hose, so trying to push it in there, it's just forcing it out the bottom. So as you shovel it in, it stacks up because you're not pushing it that much force down the stem wall with a shovel. As far as crack control joints go on the slab, they're recommended every 225.
All right, so this is not going to be really handling crack control, where you have to worry about that crack control, what he's talking about. But he's putting it in there anyway. If you got crack showing up, your post-tensioning is not doing its job. It's doing what it was told to do, but your post-tensioning must be wrong. Let's watch the
square foot on the big slab is what they call for. So they're going to saw cut that the very next day.
Let's watch them walk on this damn post-tension again.
But as for the garage, patio, and entry, those will be wet cut today.
All over top of it. Get off of it.
And you'll get a chance to see all that in action. The guy you're looking at right now, he's your setup, man. He's all garage door will allow for it as post-tension cables.
Let's hear what he says. Post-tension.
This hillside are designed for RVs, boats, whatever you want. It'll accommodate it. And this is in the Laughlin Ranch area in Bullhead, Arizona. We've got all the plastic chairs on there holding up the post-tension.
as the guy stands on it.
Cables. You know, it's interesting. I was talking to Marcus a little bit about these post-tension cables, and you know, a lot of times they don't maintain perfectly straight from one end to the other because they're not tight.
Yeah, that's not acceptable to say that they don't maintain straight. You can lay them straight. You can drape them straight. You can lay them straight. Profile them straight. You need more chairs if it comes down to it, but it's this guy's fault if they're not straight.
So as they tighten them, you're putting pressure sideways on them, and that's when you actually get cracking until the other cables. Now, if you could pull them all simultaneously,
yeah, he's wrong about that. But look at this, 2 feet on it. This guy and this guy, just killing me here. Pushing down on the chairs, of course, changing the profile, defeating it. These engineers don't specify that, and they're not there saying, look, you cannot do this. All right, it's just wondering why so many post-tension slabs have issues. It's because of the lack of post-tensioning, some of the PSI arriving too soon because of friction created by the wrong profile. And people, it's often because of wrong location, because these guys are stepping on the post-tensioning, driving down the changing the profile of it.
It would counter each other in both directions, but you can't.
Counter each other. See, this is permanently down on the floor now, on the ground. It's done. He's now ruined it. As far as I'm concerned, ruined the profile. The engineer didn't say, hey, you know what? Just go ahead and, make your own profile. Do that. Just do it's okay. Fuck it. No. All right? This is presented as flat, as the original intent, and it's no profile like this, especially right there. What are they doing? Put a column there? No.
So, anyway, that's how post-tension works.
And that's not how post-tension works. I just told you how it works. Let's look at it. Yeah, just step on it again. It's just nothing. Just step on it. The video's title put post-tension in it, so that's what I'm talking about. So now there's some post-tensioning at the top of the slab as they bring it down, the 2 directions. There's some PT at the top. Now that's because they put post-tensioning from here. This is the garage area here. And the profile, it comes away from the far end, which is slab is elevated approximately 3.5 inches. And this just stayed the same. They kept it the same there. So this PT is closer to the top. Post-tensioning is. It's very, very odd indeed. Now, it does have it going this way also. I don't see any dead ends down here. So the not exteriorly where we can see them. So I'm going to it might be an embedded plate in the dead end down here. The live end will be the other down over on this side of the slab. Let's see if we can see that when they pour the slab in, and right somewhere about here where they're filling the. Yeah, I don't see any PT these cabling coming through. All right, so it's not. This is the dead end, and this is the pockets for the dead end to hold that the post tensioning comes across. So it's going to be, it's capped off in this concrete. Well, going through the video, it looks like they put post-tensioning. See the yellow? That direction also, and there it comes underneath of this board here. There's a board. It's underneath there. Still trying to find the dead end, what it looks like. Can't see it so far. Okay, I found it. It's right here. So that's where the post tension goes through, and it looks like something like this. Now that one is so anchored there, and it might have like that. Pour the concrete around it, and there you have it. I don't think that might be the live end. I can't see outside here if this is live band post tensioning on or not. I think it is. And then again, I see something looks like an end termination there, the dead end. I'm not sure. Not sure. We have to see the end. So that's not that critical at this time. So here's the significant part of it, the field of it. And again, you saw the profile I mentioned. This is a little deep wall. They probably added some there while it sets up so they can come back and add more on top in just a few minutes. That's the pump. There's the pump operator. He's got something on his waist there, the remote. Just trying to see what I can show you here. Yeah, there's rectangular here, and then this one looks, yeah, I'd say it looks rectangular here also. All right, let's see what we got.
They're doing about 100 yards on this one, and they just started. They have a boom pump out here, about 12.
Trying to find the dead and live end in the video.
12 guys on site. And these yellow tubes that you see there, it's not rebar, it's not wire mesh, it's post tension. They're cables that run through those sleeves after the concrete gets placed, after it's cured out. They tighten those cables, and that's what holds it all together. There's no footing, if you'll notice, there's no footing around the perimeter. This is just a solid 8-inch thick 45.
Okay, there they are. They're the cables there. All right here. And so ready to be pulled. They already, no, they did not. There we go. Yeah, so this is the wall with the, gonna have a wall there, obviously. There's some, banker bolts sticking up. And so these will probably be over here also. And the spacing is significant, like I talked about. And let's see, so it's going that way. That way. So I was able to zoom in and find one for you. And there it is. So the concrete goes around there. And this is very... the engineer is not worried about the cone that's created, the pressure cone that's created on the ends, and bursting the concrete, because he didn't specify any trumpet-eyed things or spirals or reinforcement that would distribute the forces in a greater area besides the one plate.
Says do not cut post tension.
I wanted to watch this guy stomp on the post tension watch.
They're using an aluminum screed. Marcus, the owner of Aztec.
Yeah, he just stepped on it because what reason? What reason? So no respect for the post tensioning layout, and somebody paid big money for this engineering on this. And then you get these 12 professionals, if you will, and they don't understand it. You just can't consider it just like your normal nothing to just get rid of it. It's critical. This post-tensioning is critical. Now, a lot of engineers might say that, you know what, it's okay. It's within range. It's okay. But that's not true. It's not true. You want this to be however you want it, however you figured it out. All right, however you designed it. Not multiples of these, all right? It changes. That's not the design anymore, and it's unknown to you. The as-built is unknown. If they keep doing this on every corner, on every intersection, you get this. And you can see you've got, 1, 2, 3, 4, 5, 6, 7, 10, coming across here, 10, 20 more altogether, 30. You got 30 of these. Come on, that's not. It's additive, right? You got 30 of these going on. You got 30 of these going on. And you're trying to pull post tensioning. It's just a nightmare. All right, it's one side to the next. It's just a nightmare, and it's not how it should be. All right, and if you're drifting left and right. That's not how it should be. I'm a little anal about this post-tensioning, guys. I do it myself, so I'm very anal about it. Keep it where it is. Don't step on it. And I'm out there screaming at people if they're stepping on it. Get off the post. Get off of it. And I require the beep. And these guys don't have it. I require their little beeper, their grade device out there. If they step on it, set that post tension back to where it was. Measure it off, set it there. And I don't care. But I make that clear to the contractors at a time that you will not be stepping on the post tensioning. When you go to move your feet, you will not be stepping on it. And you go to kick and whatever it is, you will not be stepping on the post tensioning. All right, so I don't go for it. I don't go for it. You can figure out how to work in an area that, so when you're post tensioning, I demand it is that you can do this area here, whatever you can reach, and you won't be stepping forward again. So you won't be placing all this concrete and then walking in forward to do it. You'll be placing it and walking your way out. All right, walking your way out. But you will not be, just because it's faster for you, placing all this concrete down there, stepping in there and then trying to squeeze it off, what they're doing now. This guy's blindly walking, and this is no go. This is unprofessional to me. We're dealing with post tensioning. Unprofessional. You will work your way backwards. You will work your way backwards, and you will not be destroying the profile of the post tensioning. Take care. Love you guys. Thanks for your cat support. Thanks for your cat love. Bill, thanks for the goodies. About running out. Not telling you to buy more goodies. I'm just saying that I'm rationing them pretty good. Just telling you, because you sent the treats, so I'm just telling you that your treats went well. They still got a few days in them. I've really spread it out for them. I really ration it out so they don't treat it like food. Just to calm them down after they've been wild sometimes, they get the treat you sent. They're treats. So if you guys don't send me anything, just send it for the cats. If you want to send anything, send it to the cats. I don't need the money, but I do take your presents because I've learned that I should accept presents, and I appreciate that. And I took a while to learn to accept that, just so you know. Take care. Love you guys, and I am out of here. And hope everyone's well. Sort of a shout out to Carolyn. Haven't seen you in a while. Wish you the best. I sent you an email. If you're still just watching but don't have the energy, wish you the best. That's with the LYN on it, guys. All right. Take care. Love you guys. Bye.